This is a chart of the human brain. Now, the brain obviously doesn't have a 640K limit, but it does have different kinds of memory in different places. There's short-term memory, there's long-term memory, and to access the different parts of the brain's memory, you have to go through a kind of bus called the limbic system. Now, with a computer, it's a lot simpler, even though it seems more complicated. That's because today's sophisticated applications often require you to find and use all of the memory inside your computer. That's not always an easy thing to do. To help you figure out how to do that, today we'll take a look at high memory management on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you it's a federal offense to copy software. The SPA provides information on how to stay software legal. Funding is also provided by PC Connection and Mac Connection, and by Byte Magazine and Bix.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and with me this week is Tim Bahar, an Executive Vice President with Creative Strategies.
Thank you.
Tim, we're talking about high memory and memory management problems, which usually is in the DOS world and the 640K problem. Mac people, Mac users have their RAM problems also, and sometimes even worse problems because of the graphic intensity, the memory demands of some of the Mac applications. If you're a Mac user, here's a great solution to the problem. Here's a Mac 2 with 5 megabytes of memory right now. Using this product called Virtual 2.0, I can just go in here and put 14 megabytes into the Mac here. That means we can be running all these applications at the same time. Just to prove I'm really doing that, you can see we're in Excel right now, and I'm doing a recalculation. So you see Excel really is running. While Excel is running, I can go into here and say, let's take a look at what's going on in PageMaker, which is also up and running, eating up all kinds of memory at the same time. And on top of that, at the very same time, I could be figuring out my taxes with Macintax, crunching numbers heavily, eating up lots of memory. And not only that, I can then pull up, say, this pixel paint image of a frog. Goodness knows how much
a lot of memory used
that
there.
thing's eating up. And then I can also be running Mathematica, which wouldn't run on most Mac 2s all by themselves if we didn't add all that memory. Let's go back to the DOS world, though, which we're really going to be focusing on. Give us a quick history lesson. What's the reason for the problem with this 640K barrier?
In 1979, when Intel introduced the 8088, the addressable memory was only 640K, and it was frozen that way, with only 384K memory used for ROM, 640K addressable. And back then, you didn't have a lot of heavy, intensive programs. In fact, most of the programs only used 100,000 of memory, and you could use the rest for RAM. As a direct result of what's gone on in the computer industry, more sophistication, we've had the need now to go beyond 640K. In fact, some programs use almost that full 640K just to run. And so, consequently, you've got to look at other methods. In this case, we're going to be looking today at some other software and hardware tricks in order to get past that barrier.
Exactly. We'll be looking at several solutions to accessing and managing extra memory. We'll look at software solutions, hardware solutions, and we'll see how an operating system like OS2 can access up to 1 gigabyte of memory without any outside help. Now, as Tim explained, we need memory management products because of the inherent memory problem in the original Intel 8088 processor. So we'll begin with a visit to Intel to find out more about the origins of the 640K barrier.
The problems with accessing more memory started with the limitations of the original Intel 8088 processor. While the processor does contain over 1 megabyte of address space, only 640K was made available to DOS applications. The rest of the addressable memory space was dedicated to system ROM. Even when Intel brought out the new 286 and 386 chips, the problem still remained. The 286 could address 16 megabytes of RAM, and the 386 can handle 4 gigabytes, but the limitations of existing application software and the lack of a new standard operating environment mean most computer users are still running their 286 and 386 machines like fast 8088s without taking advantage of the access to expanded and extended memory. That's called running your CPU in real mode. To get at the memory space above 1 megabyte, the 286 and 386 chips have to operate in what is called protected mode. Intel's Mike Bemis explains.
The typical solution to getting past the 640K barrier would be to use a DOS extender. And what that allows you to do is link in a piece of utility software with an application, and that will put the processor into protected mode and allow you to access more memory than just the typical 640K.
But running your PC in the protected mode can have its own problems, since most DOS applications want to run in the real mode and so are incompatible with the protected mode. It would seem that one simple solution is to just get access to that lost 384K sitting between the 640K limit of DOS and the 1 megabyte limit of the processor, the area called expanded memory. But even that requires a complex hardware-software fix, and Mike Bemis says it's not worth the effort compared to the benefits of opening up extended memory.
Extended, first of all, it's easier to access. It's direct access. You don't need special hardware. You don't need the special software drivers that allow you to talk through the page frame. And it's extendable all the way up to 4 gigabytes in the case of the 386 processor.
Despite the improvements in memory handling of the newest Intel microprocessors, it looks like the ultimate solution to memory access lies in new operating systems like OS/2 or Unix. For the Computer Chronicles, I'm Maria Gabriel.
One of the most popular software products over the past year has been Expanded Memory Manager from Quarterdeck. And here to show off the newest version of the product is Gary Saxer of Quarterdeck. And also here with us to show off 386 Max, its newest version, is Patrick Devlin of Qualitas. Tim?
Gary, this type of software is often considered a switching device, and it's obviously a memory management director. Could you give us an idea of what the user examples might be?
Well, the best example for that is network drivers. Most people want to have their network available all the time. Even if you're running a multitasking environment like Windows or DESQview, right, you still want the network there, all those drive letters there. The network drivers, however, is going to take up memory from you. What you'd like to do is get that memory back, and so by putting it and managing the memory between 640K and 1024K and using the network driver up there, you then get more memory below 640K for your regular DOS programs.
All right, show us how you would do that with Quarterdeck's product.
We're using one of our products that comes along with QAM 386 called Manifest. It lets us peek around inside the machine. Okay. Here you can see, for instance, it's showing us that we have 539K. You can see me moving the mouse around a little bit right there. 539K. The rest of the memory below 640K is handled by DOS and some other things that DOS is doing. Now, above 640K, the EGA is using some memory. If we had a monochrome monitor, it would be using this spot right here, the 32K. I don't have one. Then the next area is used for the color text, which is what we're looking at. And this next big area is used for different ROMs, disk ROMs, video ROMs, etc. I only have a video ROM there, so I have a 160K area that's not being used, and then the system ROM. And we also have some programs loaded below 640K, and that's how we know that. That's how we know that we have 539K. Now, if we take a look at this item called hints over here that Manifest gives it, one of the hints is to install QAM 386. Surprise. You shouldn't be surprised at all. The idea here is that Manifest helps you figure out what it is you're supposed to be doing. It holds your hand, as it were, all along the way. And what we need to do right now is to manage that memory. QAM 386 is going to convert extended memory into expanded memory, and it's also going to give us high RAM management. Notice how the memory map has changed now since I rebooted. Here's the EGA graphics area, and this previously unused area is now high RAM.
It's now allocated.
And this area up here is now high RAM and the page frame. However, the memory resident programs are all still loaded below 640K. This brings up an interesting dilemma here. We have the Magellan driver and the mouse driver, etc. there, and 537K, all right, so we went backwards by 2K, but we'll get there. Notice that we also have a 31K and a 96K region available. Now, back when it was easy to figure out what to do, you would just load everything in one big spot. We have a program called Optimize, which Manifest will give you a hint and tell you to run here, and I'm running it right now. Optimize's job is to look at the size, both the loading size and the resident size of each of these programs that gets loaded into memory, and figure out the best possible way of loading these programs in. I'll try and stop the screen here as it comes up with the AutoExec file here so you can see. Notice, for instance, you can see the mouse driver there, you can see the SED driver, you can see the keyboard driver, the Magellan driver. They all got loaded into memory with a little bit of extra stuff at the beginning. And then, up there near the top of the screen, it said it tried 729 different combinations.
So it literally was running those trials to see what was the optimum.
Yes, it said, put the ANSI driver here and the mouse driver. Nah, that doesn't work as well as putting the mouse driver here and the ANSI driver here. And then the third step is, it actually goes out and tries it. It might not work. It usually does, but it might not work, so it actually goes out and tries it. So we went from 539K to 537K, and if we now take a look, we have 591K.
Yes.
And yet all those drivers are still loaded. Buffers and SED and ANSI and Keyboard and Magellan, they're all loaded. In fact, I still have 73K of memory available above 640K. Then what you might want to do is run some other kinds of programs. Now, we can do all of these kinds of things that we've seen so far on an 8088 or an 8086 using a product called CRAM that we have, QRAM. This is being a 386, of course, we're using QAM 386. Another thing that we're going to run is Microsoft Windows. You can see that even though we have the resident programs, including the mouse driver, loaded up high, I still have Microsoft Windows loaded, and I can run other very large windows as well. Here you can see I have a 564K program. In this window right here, I have a 564K program also. I'm actually running Microsoft Windows inside of DESQview.
True multitasking.
Yeah, right.
True multitasking of DOS-based programs while managing the memory. The trick is managing it.
Okay, that's great. How much does that product cost?
DESQview, DESQview 386.
That's what we just saw.
DESQview 386 is $229.95. QAM 386 is $99.95.
Okay, great. Now, I want to ask you to switch the little switch on the back of our monitor, because, Patrick, I want to turn to you. And the approach you have is a product called 386 Max. And I want you to, as you boot it up here, tell us how it's different, and then show us how you'd use 386 Max to solve the same kind of problem.
Well, where we're starting here is we're at the end of our maximization process. This is the process where we take over control of the execution of the system files so that we can find out how the end user is using conventional memory, what's using resident memory, and by doing that, we can make the same decisions for the end user, and that's what's significant about our product, is that we've taken the level of sophistication that's required to make use of that high DOS memory, and we've reduced that tremendously. In the past, people would need to work, even the most sophisticated people would take hours sometimes to make these type of configuration decisions, and then would still not be sure they made the optimal decision.
So you're saying you don't have to be a genius hacker to use this?
No, you don't. Okay. You don't. And there's one thing I would like to focus on here is a technology that we call FlexFrame.
Okay.
It deals with the fact that when resident programs load into memory, they use a much more space when they're initializing than when they actually go resident. And this is invisible to an end user and can make it difficult when trying to shoehorn programs into very tight spaces in high DOS memory. Well, I have a printout of what a program would look like as it's actually loading into memory. So if you notice what I'll try to highlight the line here so we can see.
Sure.
The PK spooler, it uses over 47,000 bytes when it's initializing, while only using 18,000 bytes when it's resident.
Right.
So if you have a 20 kilobyte available space in high DOS, this program couldn't fit. You would normally get a message saying cannot fit. Well, what we're able to do is we're able to dynamically allocate the EMS page frame, map it, and make that memory available, which is an additional 64K of memory, make that memory available during initialization so that this program can use that, initialize, and then when it becomes resident, the EMS page frame can then be reinitialized and available to serve other EMS purposes. And again, we're also offering this high DOS memory use in a Windows 3.0 enhanced mode environment, which is significant. Another issue that comes up when running in a 386 enhanced mode environment in Windows is that you only have a single resident program loaded.
Right.
And if you need the resources of that program to be available in multiple DOS windows, a lot of times you're going to find it just simply doesn't work, or you get erratic results. We've done something called instance data, which allows us to, whether a program is actually loaded high or low, we can guarantee an end user that he's going to have unique data available to that resident program in each DOS window. The example of this, a rather simple example, is that I'll open up two DOS windows.
Right. One behind, one in front.
Yeah.
And then what I'll do is I'll use ANSI.sys to change the screen colors, and you'll notice that when we go back that these changes are not reflected in the other DOS window. So if we move this DOS window down some, you can see that this changes did not affect the other open DOS windows.
All right, Patrick, thank you very much, and Gary, two impressive products. Well, one approach to enabling software application to access more RAM is to build in a DOS extender within the application. That was the approach Autodesk took with AutoCAD, and here's a report.
Designing a hotel is a laborious process requiring thousands of blueprints. But the San Francisco firm of Hornberger and Worstel has found a way to reduce the paperwork with a computer-aided design program that can access all of the PC's memory. AutoCAD Release 11 from Autodesk uses Farlap's 386 DOS extender. With the extender, AutoCAD can transfer the data in blocks of 8 kilobytes at a time, or 8 times more than with regular DOS. The architects can use the entire memory to store even the largest drawings without having to switch back and forth to the hard disk.
As we work on large projects, we often have to zoom in to see a small portion of the project. So in order to avoid the screen redrawing itself, the DOS extender helps us to get around the drawing much quicker, and we could zoom in from small area to large area to another small area very quickly.
The DOS extender runs in the protected mode of the 386 chip. It takes over as the operating system for jobs needing more than 1 megabyte of RAM. The latest release of AutoCAD requires at least 2 megabytes of RAM. But with the DOS extender, big computing jobs, like architectural blueprints, don't have to be slow jobs.
The DOS extender has been able to make us work a lot faster. Initially, we were limited with the DOS restrictions of a 640K barrier. Now that we have the DOS extender, the whole drawing as well as the program are loaded into memory. So it makes us work a lot faster than we previously did.
For the Computer Chronicles, I'm Maria Gabriel.
One other approach to solving the memory problem, especially if you only have a 286 machine, is a hardware add-on like the All Charge Card. And here to show us how that works is Shelley Sofer of All Computers, Inc. Also joining us, Margaret Johnson, systems engineer at Microsoft, who's going to show off the memory power of OS2. Tim?
Now, Shelley, up to so far today, we've mainly been looking at software approaches. But you have a hardware solution. Why would a hardware solution be a better approach?
Well, if you've got a 286 computer, you really need some hardware to allow you to get beyond 640K.
Right.
The 386 already has memory management hardware built in, so you can get away with just software. But the charge card adds memory management to a 286,
making it look like a 386.
That's right.
All right, show us how you actually use the charge card.
Well,
Shelley.
once the charge card is installed, it's completely controlled by software, similar to what we've seen earlier.
Mm-hmm.
And I've got a memory map here that we supply a utility called All Menu. You see the highlighted area up there, all these T's?
Mm-hmm.
Right.
That shows me that I have memory up above 640K. Right now I have Sidekick loaded up high, and it could be a network if I was running Novell or 3Com or Banyan. And this allows me to, I've loaded that up above 640K.
Right.
Now, I want to go back to DOS and very quickly run check disk to show you how much free DOS memory I have. 590, 480 bytes free. My Sidekick is, of course, fully resident.
Right.
Now, once the hardware is installed, it allows you to do on your 286 what we've been seeing is done on a 386. For example, if I was wanting to multitask and I was running my Lotus 123, this is a fully functional Lotus.
Right.
I have a worksheet status to show I have lots of conventional memory plus expanded memory, and my Sidekick is also resident.
But I can also multitask now.
Yes. What I'm going to do is write a very simple formula and copy that formula 8,000 cells through the spreadsheet. Now you can see at the top left of the screen, Lotus is telling me to wait. He's recalculating. But while he's recalculating, I'm going to open up my DBase 3+, and I'm going to start to sort my database. So I have DBase 3+ running, and you can see now Lotus is recalculated.
At the same time.
I'm back in my Lotus.
Still go to Sidekick?
Still go to Sidekick. What I'm going to do is copy those 8,000 cells across the spreadsheet. So Lotus again is recalculating. DBase is running. Suppose I need to do something in DOS. Very simply open up a DOS window, and here I'll just scroll through a directory.
And you're doing this on what was a 286 machine, which you've modified. Now, when you tell me I've got to go plucking processors out of my motherboards and I get nervous now, show me how difficult it is to install this thing.
Well, the charge card, we actually include all the tools that you require. Very simply, in this case, here's my 286 system board. I just place the tool, pull, CPU comes out. Then I get the model of charge card for my computer.
So that's the charge card itself.
Plug it in, take the CPU, put it back on top, I've just upgraded my machine.
Okay, well, it looks reasonable. And what's this all cost?
The charge card retails at $299.
Not bad. All right, we want to turn to another approach now with OS2. And we've really been looking, if you will, at fixes, I suppose, to the problems in DOS.
Right.
And with OS2, you're really kind of starting from scratch to deal with this memory problem, aren't you?
You bet. OS2 is the first operating system designed for PC that takes advantage of mini and mainframe abilities. It was designed from the ground up to get away from those limitations of DOS. Let's look at all these solutions that you've been proposing. We've been restricted to the 640K barrier. We've had expanded memory. We have EMS 3.2, EMS 4.0. Then we go into extended. We have the extended memory manager. We have N15H. I mean, they're all conflicting, and they're all doing different things. OS2 just gives you a straight 16 megabyte addressable area or 1 gigabyte of virtual memory management.
So we have a clean operating system actually going past the 640K barrier.
A clean playing field from the get-go.
Show us in an example here what the advantages would be of this access to resources that OS2 offers us.
To understand the advantages, you also have to understand the other sophisticated features, and that's the priority preemptive multitasking abilities of OS2 based on threads. And you also have to understand a different mindset. There's been a confusion with that. OS2 is really ideal for those workstation environments that are working with distributed applications. A lot of data on a DB2 database, for example. We see our corporate accounts extremely interested in OS2 to address the needs of getting data off of a mainframe or off other servers and tying them all together in one huge sophisticated application. The executive information system, and we're going towards the information at your fingertips approach.
Let's see it, Margaret.
Great. Right now, I'm collecting, the scenario is I'm a product manager and my product is Fancy Pants. And I work in an environment where I have access to mainframe data, and that's continually being downloaded to me in real time by this 3270 emulation program. Meanwhile, I'm creating my layout in PageMaker, which is quite a huge, sophisticated application. So I'm going to go ahead and take my mainframe data and put that into a file. In the scenario, it's as easy as closing the application, but in reality, it's a little bit different. But since we're in scenario land, I'll go ahead and place that documentation, this 200K file, inside PageMaker. Now, if this had been Windows or other DOS apps, I'd be seeing an hourglass, or I'd be actually going out for getting a cup of coffee.
Possibly couldn't even do it.
Possibly couldn't even fit the whole thing in. But with PageMaker, because of the ability of threads, and threads allowing multiple sources of execution within an application, I can do other things within PageMaker, or I can go and use other OS2 applications. For example, the CPU monitor program, which is actually monitoring our CPU usage, is sharing time slices with this pagination.
So in reality, we're getting a brand new operating system with multitasking features for the DOS platform.
For those environments, for those workstations. And I would take it a step further in saying for the sophisticated user at this point, for those workstations in a local area network or wide area network environment, or server applications. For example, OS2 is the foundation for our network operating system, LAN Manager 2.0.
Now, what's the status of this version of OS2 right now, Margaret? Where is it?
The current version that is shipping is OS2 1.21. And that's what LAN Manager sits on top of today.
Okay. Thank you very much. Thank you, Shelley. That's our look at high memory management. Stay tuned now for this week's computer news.
In the random access file this week, Computer Accessories has introduced a new input device for PCs that's perfect for presentations. It's essentially a remote control mouse that acts like an interactive touchscreen. The hardware consists of a camera that projects the PC image onto a large LCD projection screen. You then use an electronic pointer with built-in mouse buttons to control the software. The high-tech input device is called the Proxima Cyclops. BMC Micro Industries has developed a new kind of hand scanner which lets you scan large images without lifting the scanner. The scanner software remembers where the scanner is, so you can scan down one column of a large page and then just slide across and scan up the next column in one continuous motion. Using that zigzag motion, you can scan a page up to 11 by 18 without stopping. The multi-directional hand scanner is bar-shaped and sells for $299. Well, there's yet another new object-oriented programming package that lets you develop complex applications without using any code. It's called the Brain. It uses pull-down menus and plain English commands. You can create low, medium, and high-level objects, and the package automatically maintains a dictionary of used objects to assure design consistency. You can also import other program routines written in high-level languages. The Brain is sold by the Ingenio company. It's due out early next year. The price is $795. Taking a look at this week's top 10 software titles for the PC, PC Connection reports that Adobe Type Manager for Windows 3.0 is still in the #1 spot, followed by TurboTax. In third place is Quarterdeck's Expanded Memory Manager, and PC Globe is fourth. In fifth place is Quicken. Rounding out the top 10 are PC USA, Microsoft's Entertainment Pack for Windows, Facelift for Windows, Info Select, and the new Print Shop Companion. AutoCAD says that Release 11 of Autodesk will be the last release of the popular program to support 286 machines or lower. The company says the program is becoming too complicated to run at acceptable speeds within the limitations of the older processors. Release 11 of Autodesk is due out in March. HumanCAD has announced a new program to provide designers with images of human models that are anatomically and ergonomically correct. The program is meant to be used in conjunction with specialized CAD software. The PC program, called Mannequin, will allow designers to test design objects to see if they will work ergonomically with a human body. The program will ship in January and sells for under $700. Time now for this week's Software Review with Paul Schindler.
You don't have to be Sherlock Holmes to figure out that your arm would get pretty tired if you had to hold this up all the time. Yet for vision-impaired people, it's really difficult to read the tiny type on a PC screen. Macintosh users have had solutions for this for some time, but now PC users have eye relief. Now, there are two versions of this large type word processor, one for laptops and one for PCs. Eye Relief is a very simple ASCII word processor, and it doesn't pretend to be anything else. It comes up automatically in whatever size you want. You can scroll through menu choices one by one. Under the video menu option, your choices run from jumbo to tiny, that is normal, with many gradations in between. It also has colors, and those are more important than most people think. They can make a difference to people with color-specific vision impairment. You can also change the spacing and the cursor blink rate. Printing is rudimentary. If you have a laser printer, you can produce large type output. Otherwise, you have all the usual editing functions, including word count and search and replace. Eye Relief is just $300 from Skisoft in Lexington, Massachusetts. For the Computer Chronicles, I'm Paul Schindler.
Mirror Technologies has developed a full-page display for use with the Macintosh Classic. Since the Classic doesn't have an expanded slot, the display uses an internal video board which attaches to the logic board. A 15-inch display is available for under $700, and a 19-inch dual-page display sells for just under $900. Well, finally, the popularity of the computer science degree has dropped on college campuses. The Department of Education has announced that the number of undergraduate degrees awarded in computer and information science has dropped for the third straight year. According to the Washington Post, students entering computer science say the major is both time-consuming and tedious. But then again, what major isn't? That's it for this week's Computer Chronicles. I'm Maria Gabriel.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you it's a federal offense to copy software. The SBA provides information on how to stay software legal. Funding is also provided by PC Connection and Mac Connection, and by Byte Magazine and Bix. For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio 44240. Please indicate program date.